Okay, in today's lesson, we're going to be looking at congruency in shapes. And what that means is, what identification factors do we need to draw a triangle that is identical every time? So I'll come back to this. For now, as always, with Physics and Learning, pause the video here, and on my slides, can you have a go at the questions? And then you can self-mark your work, and I'll put that on the slides. It's not in this video just yet. Okay, so key point 1. Congruent triangles have exactly the same size, shape. The angles are the same and corresponding sides in the same length. So let me just show you an example for this. When you have coins, I've got two 10p coins and they are absolutely identical. 50p coins, same thing. I've got some bars of chocolate. You can see the rectangles, same size, everything's the same. So these shapes are the same. However, chocolate here, same packaging, different sizes, not congruent. However, these shapes here are same size, everything's the same. And that's what we're looking for. I'm going to be doing this with triangles. A really cool real life example. Let's see if I have my card wallet anywhere. No. Here we are. Sorry about that. A real life example that's really cool is credit cards. Now, I'm not going to show you my details, but credit cards, I'll do this off screen, they have to be exactly the same dimensions, because if your debit card or credit card were all different, they wouldn't fit in the ATM machine. And that's a really cool, I'll try and hide my details, it's a really cool real life example. If they want all the same size and shape, wouldn't fit into the ATM. So let's have a look at this. So for example, if I draw this triangle here, well, we know by Pythagoras that has to be 13. If you try on a piece of paper, it is impossible to do A. So we've got here, we've got a side of 12, an angle of 90 degrees, and another side here. So we've got a side angle, side SAS, 12, 90 degrees, 5. If you draw this in a piece of paper, it is impossible to not get a triangle that goes 12, 5, 13. Don't believe me? Have a go. So these are a pair of congruent triangles. So everything's identical. So we're looking at we've got triangle 1, triangle 2. Triangle 2, what is angle said? Well, we can see here 35 and 35. What's x? Well, the length we can see is 7 centimeters. We can see that here and here. And lastly, what's the missing angle? Well, all angles, sorry, I'm in a typo here, that's angle y. An angle said at the top, all angles in a triangle have to add up to 180 degrees. So therefore, you're looking at 30 degrees there. Because these triangles are absolutely identical. You can see there. See, absolutely identical. Okay, pause the video. You've got 2 questions. Have a go. Once you're done, answers here. Can you just self-mark? And we're going to move on. Okay, another model. Congruent. You're going to see this notation coming up. This dash here, let me just get, this dash here means that this length is equal to this length here. A double dash, you can guess it, this length equals this length. and a triple dash, same thing applies. This length equals this length. And the same thing applies with the angle. A single angle equals that one. A double line equals the double line here. And the triple here. These two triangles have the same three sides and the same three angles. They're obviously identical triangles. If you don't believe me, you'll be a fool. So, here's another cool example. I've got a shape here, A, B, and C. I've sort of done it. You can see I faded it out. I'm telling you that you're going to have three lengths. If I said to you, draw me a triangle with lengths 10, 12, and 9, every time you do it, if they have those lengths, triangles will be perfect. You can't modify the angles what they come up with. So here's another example. There's 4 rules you need for identical triangles. They have to have all sides equal. We should do SSS, side, side, side. SAS is side, angle, side. And I'll show you some examples after. AAS, if I say I need a triangle with angle 40, 60, and a length of 10, no matter what you do, if you're accurate, you can only do the identical triangle every time. And the last one is a right angle triangle. Right angle hypotenuse on the other side. That's the Pythagoras rule. If I gave you, for example, a right angle and a hypotenuse of 10 and a side of 8, every time you do it, this one has to be 6. Has to. Okay. Let's show you some examples. Here's a side, side, side. If I said to you, I want to draw me a triangle with a side of 4, 7, 5. You can see me doing that here. 4, 7, 5. I've done it here, 4, 7, 5. All I've done is rotated the shape, but this triangle is identical to this triangle. Always will be. You'll see that there, not too on the scale. SAS, side, angle, side. So here's an example. I've got a side of 8.2, angle of 50, and another one of 3.3, 8.2, 50, 3.3. You draw that, no matter how many ways you draw it, this length will always equal this length. Always, 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 always. Again, AAS, angle, angle, angle. I'm telling you, draw me an angle, 76 degrees, then 42 degrees, and then a length of 15. You can see it here on the left. Do it again. This unknown length will always equal that. This length here will always equal that. No matter how long you make this, I can make it longer if I wanted to. It will always be the same. Always, always, always. Okay. Last one. This is the right angle triangle. Here's the example. The hypotenuse. So we've got the right angle here. And we've got a side of 5.2. So I can see that equals that. We've got a 7.9 here, the hypotenuse. Got the right angle. This here, no matter what it is, and I'll quickly do Pythagoras, 7.9 squared. Take away 5.2 squared. I'm rushing this now. 35.37, square root of that. 5.9. 5.947. Always, 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 that's also going to be 5.947. Always a little bit identical. Give it a go on paper if you wish. Pause the video and copy these down. Just copy these 4 rules down. Practice question. I want you to tell me each pair of triangles is congruent. Explain why. For the first one, I'm just going to show it to you. SAS. They both share an SAS rule. That's the first one. Got a little hint in the bottom right hand side. has to be SSS, SAS, AAS, or right-hand side. Have a go at that. I'm going to provide answers to self-mark. Can you now stop what you're doing, go on the Google form, it's your checkpoint, answer the questions, and then come back to the video now. Okay, lastly, before we get going. Okay, triangle ABC. What it means by that is if I draw a triangle ABC, that's your points. AB is 9 centimeters. BC is 4 centimeters. And angle B is here, 42 degrees. Okay, triangle DEF. Let's do it. Let's do anything random if we will. DEF. Well, DE is 40 millimeters. That's 4 centimeters. Angle E, 42 degrees. And EF is 9 centimeters. Well, what do we know? Well, we've got here, if we look at this triangle here, it goes side of 9. I'm going to put S. Angle of 42 degrees. And that's going to be A. And another side of 4 centimeters. S. And what do we know? We've got SAS. It's reflected, but it still works the same way. SAS. 442 degrees 9. They are congruent. They are the same. They both follow the SAS rule. These shapes, no matter what you do, are identical. They might be reflected, but they're still the same. In the same way, if I had my chocolate bars, no matter how I rotate them, they are still going to be the same. Pause the video, practice questions, have a go. Question 6, 7, and question 10. I believe in your ability. You'll be fine with them. I put the answers on the slides that I attach after this. Oh, here they are. Answers, self-mark. And lastly, application question. In your book, please draw this out. Give me the answers, and then I'm going to give you a Google form, and you can just submit your answers for me so I know you've got it correct. Class, as always, if there's any issues, I'm going to be in Google Classroom the whole time. Comment away, and I can get them answered for you the whole time when you're doing this lesson within the hour. But I'm going to post this at 8 AM, so if you want to do it earlier, be my guest.